Today's lesson is on multiplying a monomial by a polynomial. As usual, there is a video guide to go along with this lesson. If you haven't printed it out already, go ahead and pause the video, print the video guide, and then come back and work out the examples with me. So because we're multiplying a monomial by a polynomial, we should probably go ahead and define those words first, and then we'll get started with our examples. So first we have the word polynomial. The word polynomial has the prefix poly, which means many. So when we see the term polynomial, that means many terms. So polynomial is two or more terms. Okay, so we're going to be multiplying by a polynomial, so we're going to be multiplying with two or more terms. All right, our second word that we're going to take a look at is monomial. Monomial has the prefix mono. The prefix mono means one. So if polynomial is two or more terms, a monomial is one term. So we are going to be taking one term and multiplying it by two or more terms, okay? And we have some steps that we're going to use to go ahead and figure that out. So let's take a look at what those steps are. All right, so our three steps, okay? So we have A, our first step. We are going to be using the distributive property. Use the distributive property. If you do not remember the distributive property, there is a lesson on that, a previous lesson. You can go ahead and review the distributive property there. Okay? So first we're going to use the distributive property to go ahead and multiply a monomial by a polynomial. After that, we are going to multiply the whole numbers first, okay? Which are just the coefficients, right? The coefficients are the numbers in front of a variable, okay? But it's just the whole numbers. There we go. Okay, so multiply by the front numbers first. After that, okay, we're going to use some of the properties of exponents that we learned again in a previous lesson for multiplying with exponents. So that last step we are going to add the exponents. Because this is multiplication, remember whenever you multiply, you have to add the exponents of like bases. Okay, so we're going to use the distributive property, multiply those whole numbers, which are the coefficients right out in front of the variable, and then we will add the exponents. So let's go ahead and take a look at the first example. For problem number 4, we have 2x to the third, and we're multiplying that by negative 7x squared plus 2x minus 4. We know it's multiplication because the 2x to the third is right next to the parentheses. So like I said, our first step is using that distributive property, which means we are going to have to multiply each term by the 2x to the third. Okay, so we're going to distribute that 2x to the third to each one of these. So as we're doing that, we multiply the whole numbers first. Remember, I called those coefficients, the numbers in front of the variable. So we're going to multiply by 2, and we're going to multiply it to the negative 7. So 2 times negative 7 is negative 14. Now from there, for the variables, we are going to add the exponents. So 3 plus 2 gives us 5. All right, for our next terms, we're going to multiply 2 times this positive 2. 2 times 2 is positive 4x, and then add the exponents. That's step 3. So adding the exponents, 3 plus, this one doesn't have an exponent, so we put a 1 there. 3 plus 1 is 4, so it's x to the 4th. All right, so our last term, we have to distribute, again, to each one of these. So we're taking 2 times the minus 4. Well, 2 times minus 4 is negative 8, or minus 8. And then we have our x. Now here we have x to the third, but for the 4 there are no x's. So there's nothing to add to it, so we leave it as x to the third. So it's minus 8x to the third. So negative 14x to the fifth plus 4x to the fourth minus 8x to the third is our answer for problem number 4. That's all we're doing right now. Let's take a look at problem number 5. For problem number 5, we have negative 6p to the second, and we're multiplying that by 5p to the fourth minus 2p to the third plus 9. Again, we're using the distributive property for these problems. So we're going to multiply the negative 6p to the second to each term over here. So let's multiply. Negative 6 times 5 is negative 30. Remember, for the variables, you will add the exponents. So 2 plus 4 is 6. After that, we are going to multiply negative 6 times negative 2. So what negative times negative is a positive 12. P to the 2 plus 3 is 5. Again, add the exponents. All right, after that, we are going to multiply negative 6 times the positive 9. So negative 6 times 9 is negative 54. And then for the P, we bring that down. There is no P at the 9, so that there's nothing to add to it, so that P to the second stays P to the second. So our answer for problem number 5 is negative 30p to the 6th plus 12p to the 5th minus 54p squared. For problem number 6, we have 9p to the 3rd, and we're multiplying that by negative 10p to the 7th plus 5p to the 4th plus 10. So our first step here again is to do that distributive property. Take the 9p to the 3rd and distribute it to all 3 terms. So multiply the whole numbers first. We're taking 9 times negative 10, which is negative 90. And then for your variables, add the exponents. That's the rule of exponents that we've talked about in a previous lesson. So we add 3 plus 7, we get p to the 10th. Then we go to the next term. Multiply 9 times the positive 5. 9 times 5 is 45. That's positive 45. For the variables, add the exponents. 3 plus 4 is 7. So it's p to the 7th. And then the last term, multiply 9 times the positive 10, which is positive 90. And then for our variable p to the 3rd, there is no variable here with the 10. There's nothing to add to it, so we leave it as p to the 3rd power. So our answer for number 6 is negative 90 p to the 10th plus 45 p to the 7th plus 90 p to the 3rd. And that's it. We're done. All right, for problem number 7, we have negative 5a, and then in parentheses, 9a to the 6th minus 8a squared minus 10. So again, what we're going to do first is that distributive property. Take that negative 5a and go ahead and distribute that to all the terms inside the parentheses. So each one. So our first step is to multiply. We're going to multiply negative 5 times 9. We get negative 45. And then for our variables, add the exponents. Well, this a doesn't have an exponent. Remember, if it's not written, there's a 1 there. They just didn't put it in. So we'll go ahead and add 1 plus 6, which is 7. After that, we multiply negative 5 times negative 8. We get positive 40. Okay, don't forget that this minus sign makes it negative. So we have positive 40, a to the 1 plus 2 is 3. And then lastly, we're going to take negative 5 times negative 10, which is positive 50. We have a to the first here, but there is no a for the 10, so we're going to leave that as a. So our answer here is negative 45a to the 7th plus 40a to the 3rd plus 50a. At this time, go ahead and pause the video. I would like you to do problems 8 and 9 on your own, and then press play for the video again, and you'll see the answers for 8 and 9, and I'll go through those with you. For problems 8 and 9, let's look at number 8. We have negative 4k to the 4th, and we're multiplying that by 5k squared plus 9k minus 10. So I used the distributive property to make sure I multiplied each term by the negative 4k to the 4th. So I multiplied the front numbers, added the exponents. That means I got negative 20k to the 6th minus 36k to the 5th plus 40k to the 4th. For problem number 9, we had 6v to the third, and I multiplied that by 3v to the fifth minus 8v to the fourth plus 3. Again, I used the distributive property first, so I multiplied each term inside the parentheses by the 6v to the third, multiplying the whole numbers and then adding the exponents. So here, 6 times 3, we got 18v to the third minus 48v to the seventh, and then plus 18v to the third. So that should be your answer for problem number 9. And that's the end of our lesson on multiplying a monomial by a polynomial.